Hello everybody and welcome back to the stream. So last week we added constexpr. Contrary to the syntax highlighting here, it's a C feature and it's essentially like the same thing as in C++. You can use a variable at compile time. Following constexpr, we also needed to implement like constant evaluation for that. Because the initializer of a global, this needs to be like constant memory. And as we can see in the bytecode, this is like directly in line, like this is evaluated and stored in here. It's not impressive if it's just a number, but we can also do like arithmetic in here, and then like this multiplied 11 times 2 is 16 in hex, and this is then printed properly. I did a tiny bit of refactoring in between streams. Namely, I added the where we do the constant evaluation. Previously we heap allocated a bunch of memory. So inside the bytecode, we heap allocated memory to store the result. Then we evaluated the expression and stored that in that heap allocated memory. We then returned heap allocated memory when we're done with constant evaluation and access it. I've since added a feature to CLOP to get rid of this double heap allocation, namely the ability to add a global variable that is native, like stored in native code and doesn't have a definition in the bytecode itself. So we add a native global. We then store that in that native global, and when we create that global, we define that native global to be the data of our vector that we're returning. So that way, after constant evaluation, we can directly store that inside native memory, which we then return. One thing that we didn't do last week, so we can create a constexpr global, and then we can create another global, and when we want to initialize it, like so, this breaks. So the reason it breaks is when we, right here, we reach unreachable code inside the code gen. The reason for that is quite simple. When we do code gen for the expression that refers to the other global. We're doing that in a brand new module. This module does not contain the globals. So it's empty, it does not contain global, so we can't access it. So we're reaching the unreachable code. We're reaching line, what is it, 350? This is because we are somewhere in here, and we are attempting to look for that global, but it doesn't exist. Because the module is empty, each evaluation happens in isolation. And like there are two ways we can fix this. Probably the proper way is to independently figure out the dependency chain between all constexpr globals. So in this case, we need to evaluate global first, and then we can add the already evaluated globals to that module so we can access them. We can also do the hacky way, which is what I'm going to implement because it's easier. Instead of copying the value of global, we can just inline the expression at this point, right? We can inline it and evaluate it twice. This is potentially problematic if the expression has side effects, but because this happens at compile time, the expression is not allowed to have side effects. So we can just evaluate it multiple times. It's just more work, but it's not too expensive. And so what we can do is when we access a global variable and we do not have a module, right? If the context module is null pointer, right? This means that we are currently doing constant evaluation. I'm pretty sure we don't set the module in that case. Constant eval. Right, we pass null pointer for the module to the context. Right. No, we pass it to the AST. The AST is null pointer. Okay. So the AST is null pointer. We are currently doing constant evaluation. Then we know that the only valid identifier expressions that can happen during constant evaluations are identifiers that refer to other constant expressions. Right, if we check that here in the compiler, somewhere is constant expression. Not in the compiler, in the AST. Is constant expression. So in this case is named constant, right? Which has to be like an identifier yeah, it has to be like a variable declaration that is constexpr. So if that is the case, right, we can have a variable declaration, but the variable has to be constexpr. So if we're having a variable declaration, then instead of attempting to access that variable, we just evaluate its expression. So evaluate its initializer instead. So we can assert that decal is constexpr or something. What's it? So we've got flags, and one of those flags is its constexpr. Okay, so if var decal flags and without variable decal is constexpr. So we know that the variable has to be constexpr. And then cannot access non-constexpr variable during constexpr. Which also means that the variable has an initializer, and we're just recursing and evaluating that initializer. Evaluate its initializer again. And now it works. I mean, it works because I've changed the code. Okay, apparently we're still not quite. 3, 3. So why aren't we reaching this code? Right. It's a variable decal. Oh. No. So it's initial. We need to return. The structure of this code is that after we hit a happy case, we return. Otherwise, we reach this unreachable. So we did the correct thing. I just forgot the return. And now it works. So by sort of inlining the global expression like so, that works. The other thing that we could refer to a function. So a function is also valid because that's also a constant thing. So if we're having a function decal that we're referring to, I mean, like we want to push this address, but we don't know the address. That's okay. So here we can't do the hack because like the value of that thing is the address, and we don't have the address of the function because it's not contained in the module, so we don't know its thing. That's annoying. So for that we need to do something properly. We also can't reach that case because we don't have function pointers, so we don't need to support that. What we do need to support though is that we can like this is a non-constexpr global, and this is its address. That is something that we need to support, which is not tricky. But okay, let's commit that first. So support constexpr variables referring to other constexpr variables. So this means that we want to know the address of a global, which means we need to declare everything in the module at least. We don't need to provide the definition, but we do need to declare anything. So that means we need to change this interface. Since this function isn't actually called outside, let's make it private. So constant eval. And then that still works. Okay, and then we want to pass in a module that contains all the declarations. So we pass in so want to pass in a module. So we've got two constructors, one that takes an AST and one that takes a module. The module mod. And the idea is that this module will contain all the declarations. Actually, I don't need, I can just pass in the same context. So let's pass in the same context. Let's pass in that context, and let's also store the VM in that context. That could be. Okay. So we pass in the context, which means that now we have access to the declarations. Context, and here we pass in the AST and the VM. We pass in the AST, and we pass in a VM. VM. And then when we evaluate it, we access the VM of the context. Then we also need to know whether or not we are currently inside constant evaluation for that other thing. So we need to set some flag. Context dot in constant evaluation true false. Bool in constant evaluation false. And then when we do the identifier expression right here, context in constant evaluation. Okay. So now the this thing, let's try that again. That should still work. Apparently it does not. Why is that not working? Where the hell are we? Why is that crashing? What's going on? Okay, it's something. Okay, we're crashing inside new, which isn't great. What did I do wrong here? Let's see now. Let me get sanitizers. So, keep use after free. Huh. That's interesting. Why? So we're using what has been freed? The module? No. So we are using heap use after free and blah, which is inside this region, whatever, which has been allocated in create module. So the module has been destroyed and where's the free? Freed here. Code gen lambda operator, line 959. That's freed things. Oh, right. We're destroying the module. we shouldn't destroy the module. Okay, so that still works. Okay, let's try it. So int global address. So that one still doesn't work. Oh, that's a const int pointer. Why does that one know? Ah, wait. That just happened. Oh, okay. So the reason this works is because we're processing the thing one by one. By the time we're doing constant evaluation of this one, we've already emitted the previous global, right? And so it just works. When we look up the address of the global, it's already declared in the module because this line has been processed first. So we don't need to do, like, the idea was, I thought we needed to now iterate over all the globals and manually add a forward declaration. But because C is processed from the top down, this happens automatically and we don't need to do anything. So we can just take the address of the global. So that's cool. I wonder, but like, is this actually now necessary, this hack? Apparently not. Okay. So, wait, what's going on here though? I know what's going on, this one. So this now also works without, like, this entire previous commit was completely unnecessary. Because when we reach this code and we're not in constant evaluation, we look like we attempt to find the variable, push its address, and load from it. And by the time we are evaluating this one, we've already processed the global and added, like, defined it. So that just works. I mean, like, we are loading it at compile time, which, I mean, is a bit wonky, but since it doesn't change, that's really cool. What we need to do is, like, this global that is added here. These ones are added by this call, where we're adding the native global, which obviously, like we shouldn't add those repeatedly. So let's add it once when we create the context. Oh, man, that's a bit annoying that let's actually, what we could do, what I'm just thinking, that instead of storing it in this native global and then copying it over and then specifying that as the initializer, whether it's possible to, like, store that inside the global directly by making it mutable. And I mean, it could work, but I don't think Lauf supports that, right? Because we can't, like, store stuff. So what do we do about that? We could create, like, the native global once inside the context, but then we are always having things. I mean, in principle, it's not problematic that we're adding those, because since they're native data, they don't actually take any space physically. Like, we just have this extra entry inside the dump code here, so it's probably fine. Or I could just remove them afterwards. So they're added here. So internally in module, we have, like, a linked list of modules, but we can't really delete because it's a singly linked list. We can't delete them. So okay, let's just keep them and give them a correct name though. Global debug name. Set global debug name. Global constexpr initializer. Initialization result. I need to specify the module for some reason for that. Okay, so we give it a proper name, and then when we print that, yeah, it's like it shows up as the name. It's printed like the bytecode. They're not printed as native globals, which I know why. So haven't updated this dependency yet, because I forgot to implement that initially. So we need, I mean, that looks to be this. This one. Properly yank this one. Do you not want to? Copying one thing from one window to another. The live stream. Okay. Oh, because it's in a different outline. I'm pasting from the wrong. Okay, let's copy that one more time. And let's paste it. It ends with A. Okay. You should be able to use your tools properly. Okay, it's still printed wrong. Okay, never mind that. So apparently forgot to push that. Okay, let's full commit that as properly. Actually, let's amend the previous one. Okay, so that's the proper fix for that. Just want to see, like, we can do arithmetic on that. Like, this is still valid, but it should panic because, I mean, this is the end pointer. This is fine. And this is actually, wait, why is this 16? Like, does it actually work? We've got a memory leak and we've got a panic for the invalid address. So apparently this doesn't actually work. Oh, I mean, of course, it's an invalid address. Yeah, right. So this works. Find it interesting that the representation for... this is the representation for global address. I was looking at this one. I thought, oh, it's funny that the address has the same byte as the values. But no, this is the address. Okay. So we can do global +1. Obviously, we can't dereference it because it's the end pointer, but we can initialize it. And now this +1 is the 8 here because we are 8 byte further in. And we can do +2. And then we panic for an invalid address. I'm guessing when we access it. I mean, we should also panic at this point because we're doing pointer arithmetic and we're not allowed to do pointer arithmetic. Because, like, this incremented past the allocation thingy. So why aren't you panicking? Right? We should hit this assert. This one should be hit because we're doing arithmetic like we're doing undefined behavior. So this is where we do an arithmetic built-in, where we're doing an addition on pointers. So yeah, right, this line is the one, right? We're hitting this one. But right, yeah, leak sanitizer doesn't work in the debugger. So we should evaluate this one sometime at one point. Oh, right. So when we evaluate the address, we don't panic just for computing an invalid address. We are only panicking on access, right? This one happily allows an offset, like an increment past the offset, past the buffer of the allocation. We're panicking it like it's lazy only when we access it. I'm pretty sure the standard says something different. The standard says that when we do pointer, the result has points past the last element. If the pointer and the result do not point to elements of the same array object, the behavior is undefined. So this should be like the addition itself should be undefined. But is this behavior specified? Ah, yeah, right. This may invalidate the address. So we need to let me add a to do because like we need to add a load function for that. So to do ensure that the address is not invalid. No. So we need to like add some built-in follow to do that. Okay. Let's commit that. So what I wanted to do for this stream, actually what I planned on doing was tackling exciting things such as linkage and storage specifiers. The motivation was this piece of code in the compiler. Where we are parsing something like here. Where we are parsing like a bunch of specifiers has gotten really ugly because we need to create like a variant of temporary enum values, and then we create like this weird type with storage class. And I wanted to make that nicer. And so while we add that, we can also add like the remaining specifiers. So there are two things. So it's about parsing those specifiers, except for thread local and type def. So there are two things. The first are the ones that specify the storage class. For example, register specifies that something has the storage class of being in a register. Or auto has the storage class like it's the old meaning, like the C meaning, where it means that something is local, like a local variable, which is like the default. And then we also got like linkage, which specifies whether or not a symbol is visible in different translation units using external static. So linkage itself, there are three linkages, three kinds: external, visible outside the current translation unit, so like external functions; internal, things declared with static, they are not visible outside the current function; and none, which is essentially things inside a function, because they are not visible anything anyway, right? So like what it says here is that everything that is declared with external linkage, they all refer to the same thing. Everything that refers to internal linkage, even though they have the same name, if they're in different translation units, they are different things. And an identifier with no linkage is like unique, which is like a weird way of phrasing that. Right. So, and then also we've got like the storage class, or the storage duration rather. So we've got like thread local, static storage duration lives the entire runtime. Automatic storage duration lives inside the function. Register, is that a storage duration? I mean, let's just treat it as a storage duration, and things like that. So we need to add more metadata to a compiler. So declaration. Decl. So every declaration has a linkage. And we've got external, internal, let's have none first. So 0 means none. And then we give everything, can I use, no, I'm already using the user data. So yeah, let me change it. So we're reusing the user data. So dryad child user data. Like there are spare bits in the base class that we can reuse for our own data using this macro. So user data, linkage, and this is unit 16. So this is like derived classes can access and set it, and the other ones can only set it. Linkage. This doesn't need to be called. Okay. So why do I provide a setter for that? I don't think this is ever called. Okay. So now everything has a linkage, a declaration. This means because we are reusing the user data, we can't use the attribute again. So we need to manually add them, which means I can actually store them in the proper type. Flags. Initialize them here, flags. Flag. I should at some point investigate in like proper, like not these plain enums for bit fields, but like the overload the operators. I know that the parameter declaration always has no linkage. So this is always none. I'm guessing let's make it the default. So like so. Let's make it the default. And for everything else, we want the linkage passed in the constructor. So linkage, set linkage to linkage. And for a function also has linkage. That's, yeah, I mean, it's related to the name, so let's add the parameter here. And then in the compiler, since we are just add the default linkage, so we know that when we create a variable decl right here, so let's say that if we add global scope, then just make everything. I mean, we can implement the semantics a bit correctly. So the var linkage at global scope. Yeah, I mean, like, isn't external the default, right? External, otherwise linkage none. So if we're not at global scope, then it doesn't have linkage. I believe. So where is it? Storage class specifiers. They shall have no explicit, like, the storage class only allows extern. Where does it specify like the default? Maybe specified here. Declared if so if it has no storage is the right, so it has extern, like extern is the default. Okay, so extern is the default, and then we pass the linkage to the constructor. I don't know the order of arguments. Linkage flags, and for a function we've got the linkage symbol. Okay, this might compile, probably won't. Right, so same deal. Right here, we're passing a function definition, and we're passing a global declaration. So this is obviously always extern. Zero linkage external. Okay. Yeah, it takes me sanitizers, takes some while to compile. Let's get rid of a bunch of to-dos. Okay. So this hasn't changed anything because we need to handle it in CodeGen as well. So let's, when we create a function declaration, we create a function. We insert the function. So if declaration linkage is cloud linkage external now Adam, we want to export that function. This doesn't change anything if we're generating bytecode. And also apparently not shown up in the when we print things, so we can't actually verify that we are hitting this piece of code. But when we generate assembly code, which is also possible with Lauf, then it's marked as exported. Then when we add the global variable, we do the same thing. Although I don't think I can currently export globals. Yeah, I can't actually export globals. Let me just, yeah. I can't export them. Okay, so I mean, it's a bit silly since we're only having a single translation unit anyway to like implement external versus internal linkage, but we need to parse it at some point anyway, so let's just do it. Okay, so the second thing is, let's get rid of this one. So a variable has like flags, but those flags, so more precisely, we've got the like we want to know whether it's marked with one of those. For a variable can also be marked with auto, register, red local, which I'm not supporting currently, and we won't support for a very long time probably, and constexpr. But the issue is that like constexpr can be combined with the other ones, I'm guessing, except for register, probably. Oh, it's probably said somewhere. Right, so we need an enum and like a boolean. So let's get rid of those flags and instead add the enum, enum class storage duration, which can be automatic. Let's sort them from longest to shortest. So static, automatic, register. Get rid of those flags, and instead we've got the linkage, then we've got the name, then we've got the storage duration, storage duration SD or something. I don't like Boolean parameters, but okay. Let's constexpr like so. And then instead of the flags, we are having the storage duration bool constexpr, and then so storage duration constexpr is constexpr. Bool is constexpr. And then we've got the storage duration. And now a bunch of code breaks because we've been calling the flags. So a static L value storage duration equal to zero storage duration static. That one's easier, that one is constexpr. This is okay. And then we need to have like the type qualifiers and the storage class specifiers and the type specifiers. And they are all technically different enums, but I'm going to, my language server died at some point. so they're all different enums, but I'm going to unify them into like one single enum. Which is the, what's it called, storage class specifier. I mean, no, not storage class, because they're also type specifiers. What's it called in the grammar? Declaration specifier, right? Storage class, type, or function. What's a function specifier? No. Anyways, storage class specifier. So we've got the type specifier. Type specifier, not storage class. Declaration specifier. Those are the storage class specifier. And they are auto, constexpr, extern register, static. Constexpr, extern register, static. Extern register, static. Since they're all keywords, it's a bit annoying to specify. And then we've got the declaration specifiers. It's a symbol table that matches, that gives us a declaration specifier. And then we map those to declaration specifier. And then we also mapping. So define the appropriate keywords. So we've got auto maps to declaration specifier auto. Constexpr maps to declaration specifier constexpr. Extern maps to extern register maps to register, static maps to static. Type qualifiers are still separate. And then I need to reserve the declaration specifiers and follow the error messages. So type with storage class. This is the type. Then we've got a storage duration. And then I've got a rule is constexpr. So then, or rather, so the idea is this type is, so that's the type that is used where is that used. When we are parsing like the decals, where's that actually created? Right here in the decal specifier list. So we just pass a bunch of decal specifiers and we want to like, right, so we pass the decal, we can already like translate the type. We can, okay, so bool is storage duration or constexpr. So because this also like, we're using the same grammar protection to pass both type names in a normal declaration and in stuff like a cast declaration, but you can't have a cast declaration like you can't put constexpr in there. But they still get the same type, so we need to check for those. So if this is not and we also have like linkage in there, which is annoying. Okay, so you know what? Okay, so let's all make those all optional. Alright, that's a good idea. I guess optional bool is a bit overkill. Okay, so if we're inside the cast, right, or size of our line length, we must not have linkage, we must not have storage duration, and we must not be constexpr. Okay, then we issue an error message. Continuing on. Right, here in the declaration specifier list, this is now simpler. We're just passing a list of declaration specifiers. And then we get a vector, not of a variant, but of declaration specifier. And let's, for consistency, rename you to decal specifier, since the production is called decal specifier list. Decal specifiers. We don't need the variant include. So we have an optional storage duration. Optional is type, optional qualifiers. This function is so messy. So we're now passing a specifier inside the specifiers. Typo specifier. And then we are switching over those. Can I get... It's not in silo of decal specifier. I'd really like to get you, thank you. Okay. So void int apparently we forgot about char. That's weird. Char's right there. Signed and unsigned, and finally short. Okay, so you can go. Then this can also hold a type quali. Wait, why can this hold a qualifier? This can really also hold a qualifier. Okay. Let's not too worried. Also add the type qualifiers. Const volatile. I don't think so. Type specifier qualifier can be one of those. Type qualifier can be one of those. Okay. So also const volatile and restrict. And then you no longer map to, you also map to a decal specifier. We need to keep this one separate because after pointer we're only passing like those subsets to like figure out what's the qualification on a pointer. Like you can't put constexpr in there or extern. It's only a pointer like to const or something. So this is a restricted subset. Which means that this one is now the decal specifiers. Let's do it like so. So the decal specifiers are a strict superset, which means that we start with the type qualifiers and then add the other ones. Okay, that's quite elegant. So now we're passing out specifiers. We now need to add decal specifier const volatile restrict. Then we need to handle this sort of logic. So this is now, we need to translate the type at this point. So this is a qualified type const. Then we break. This is the qualified type volatile. And this is the qualified type restricts. And then I need to add braces because the switch statement is such a great pattern matching tool. Okay. And then we finally having the storage class, which we've removed. But like the similar logic remains for the storage duration. Okay. Okay. So when we having auto, we are setting the storage duration to C-love storage duration automatic. When we're having register, we are setting it to register. And when we're having static, we are setting it to static. Okay. Then we need to know whether or not it's constexpr. So if it is constexpr, we're setting that to true. I don't need a optional for that, so we're just setting it to true. And then we can also get the linkage. Let's sort them like so. Linkage. And here we're setting the linkage to C-love linkage external. And here we're setting it to static. Okay. What is internal? Internal. Okay. So now there are a bunch of it's such a horrible way to specify all of those things. It's so messy to like look at what we are having to do. We are setting the type of storage class. Let's rename that to type of quals. Type of specs. Okay. So type of specs. What do you want? You want a type, you want a linkage, you want a storage duration, and you want whether it is constexpr. Okay. So that's that. Now we need to check for a bunch of invalid combinations. For example, at most one storage class specifier may be given. So of those ones, only at most once. So let's add a check. Bool has a storage class specifier. It is initially false. Has storage class specifier is 2. It's 2. It's 2. 2. Oh, okay, at most one, except those combinations. Really, auto can appear with anything else? So we can have a static auto, and this is then 611.5, 611.5. Sure, thank you. Auto may appear. Okay. So this doesn't work. We have to manually check the combination. Okay. So if the storage duration already has a value, we log in error. Okay. Invalid combination of declaration specifiers is not the error. So constexpr may appear with auto register or static, so not with extern, I'm guessing. So I'm guessing no combination is allowed except for those. So auto may appear with all others except for type def. Why does auto? Okay, let's ignore that rule. That rule is silly. Okay, thread local we don't have. Constexpr may appear with auto register or static. So so for the storage duration can only be like the storage duration can be set with static, automatic, or register. So essentially all is allowed. So the storage duration is irrelevant, but the linkage needs to be unset. So if linkage has value, we log an error, and then we set the linkage to celof linkage none. Okay, extern. So if we already have a linkage, then we log an error. Register avoids the storage duration, so if we're already having a storage duration, we're logging an error. Static sets both linkage and storage duration, so let's set the linkage first, so let's check for the linkage first. Okay. So if we're having those, then we log an error. This now computes, I believe, the correct combination of those things. So now we've got a list of type qualifiers, which we are parsing into like a literal list. Of Decal specifier, standard Lexias list. So we're parsing a list of type qualifiers. Right, for a parameter decal. So type with specs. So if we're having a linkage in a parameter declaration, or we are having a storage duration, or we are having constexpr, then invalid use of storage class specifier. Because those are not allowed. Then we are checking. So this checks that the initializer of a global variable has static storage duration, and it needs to have static storage duration and needs to be constexpr. Since we are implicitly making everything that is constexpr also static storage duration. No, we're not, but we can. We should. So if my decal is constexpr, this is all that we're checking. Because right here, when we decal specifier list, we are giving everything when we have constexpr. We are also giving it static storage duration. I mean, intuitively, this makes sense. However, no. I guess not. Okay, then done. I don't care. So right, we don't have flags. So we've got ties back. So if type back dot is constexpr, then we need to make the type const. Otherwise, so the default linkage is current scope So if the current scope is the global scope, then the default linkage is external, otherwise the linkage is none. Which means that here I can just say, what's the constructor? So variable decal takes linkage name as the constexpr. So linkage is tiespec.linkage.value or default linkage name tiespec.storage duration value or default storage, and then we put tiespec.constexpr. Then we copy that one. Here we can tiespec linkage.value or default linkage. And then we also need to define like a default storage. So if we are in global scope, the default storage is storage duration static, otherwise it is automatic. Okay, we're almost there. Right. So wait, why is what exactly is this error message trying to tell me? Now my action function, we want to call back the callback of, so we are passing some lambda at 143p. This one that passes a declarator. Right here. We changed this type a while back. So this is a seed of decal specifier. Without zero. So this is a decal specifier. These are the qualifiers on a pointer decorator. So auto qual is C-love qualified type unqualified or auto who false. We switch our queue. If it's const volatile and restrict, making you an int, specifying a default value where we not passed. Right, we will never have those keywords because we simply don't pass them. And then here we are passing qual. Here we are applying that. What's the qualifier type? We need to know C-love qualified type. Qualifier T. Now matching function to call to lambda at 143p. That's still our lambda? Alright, because this is probably an optional vector of things. If false, this can be done nicer by refactoring, but I'm not going to do that as well. Okay, so now we're compiling again, which is good. Again, we don't see any changes at all. So we should probably implement something. I'm surprised actually that this function didn't need any changes whatsoever, which is interesting. Is it actually correct? Anyways, let's add the what I wanted, print something out when we pass a declaration. Print a declaration so we can like get some feedback of whether what we're doing is actually correct. So when we're parsing a declaration, a declar, we're printing the type. Let's also print its linkage. Linkage. No prefix, otherwise external, internal. So now we can see the linkage in the AST. After we're done compiling, I should disable the sanitizers. They slow down compilation. So now we've got like an external function main, and not external global, right? Because it's a constexpr. Constexpr. Where does it? I mean, I think I read it somewhere that constexpr has no linkage. And constexpr. No, constexpr. Is it somewhere in here on linkage? Why? Maybe I misunderstood something. Because I don't think it's correct. Like you can have like a static constexpr. Like I'm pretty sure that's a thing. Yeah. So that's a bug. But we get the linkage. Let's also get, after printing the type, if we're having a variable declar, let's also print its storage stuff. No trycast. If we're having a variable declar, then switch our float duration. Static auto. Yeah, let's do nothing for automatic because like that's the default. Register, and if it's constexpr, we are also printing constexpr. So variable global of type const SN64, which is static constexpr. Right? Let's print it like so. So nicely formatted. And then we've got function main, which is external. Okay, so where we're parsing a decal specifier. Decal specifier list. In this beautiful function in here, we're setting constexpr, we're setting it to linkage none. Oh, right, it is static. Okay, so linkage none. Why are we setting it to linkage? Oh, right, the linkage was, that was the thing. File scope identifier with constexpr means internal, not none. Okay. What if it's not at file scope though? File scope identifier. The following an identifier declared to be anything other than the object or function. Okay. Function parameter, block scope identifier without extend. So if it's constexpr, implies internal linkage, but only at file scope. Otherwise, it implies file scope. Okay, so this is really confusing written because this states like under this condition it has internal linkage, and this says it has no linkage if, right? So it's the other way around. I would like just write 3 paragraphs: no linkage if, static linkage if, external linkage if, instead of like this weird mix. So we've got internal linkage in those 2 cases. So static, sure, and constexpr only at file scope. So here we need to check that if we are at file scope, what's it called? State, current scope, state, global scope, then it's internal linkage. Otherwise, we don't set a linkage. Right. Except that this, so now this is static on constexpr, but the change we just made causes an error. Because now if I do that, the constexpr already redundantly sets the linkage to static, but I'm pretty sure Clang likes it. Apparently Clang doesn't support constexpr yet. But Clang likes it in C++ mode. So we should support that. So the linkage is internal, but we need to allow a redundant static or storage duration. So let's allow a redundant static. Like so, which of course means storage duration. If it has a value and that value is different from static, not the storage duration, the linkage. So if the linkage has a value, and that value is not the value we're about to set anyway, so we allow a redundant linkage. It's so confusing that static sets both the linkage and the storage duration. Why are we still hitting that code? If we're having a value and that value is not internal. Oh, right, because right here, and we also need the same logic here. Linkage internal, and while we add it, we also need to handle duplicate constexpr. Okay, so now we can have a static constexpr, please. This is such a horrible way that we have got like this bunch of flags that we all need to handle. At least they're order independent. But okay, so now we've got an internal global that is static constexpr. But of course, the way we're writing it like so, we're also allowing... we're actually not allowing that. I thought we are allowing that because like we're hitting this piece of code where we set the linkage, but it's already internal. But we are getting caught out by that one. So we already set the storage duration, so we still get an error. So we're not allowing that. Okay. So that's that. That's that bug. Then somewhere in here in the global declaration, I'm pretty sure we are also not handling everything correctly here. So we've got a type spec. Because when we do a function declaration, we need to respect the linkage value or external linkage. Tie spec its linkage. So we want the scan result value and then its linkage and then external of it. Okay. So now we can do something like so. We can have main function that is static, which isn't allowed, but okay. So that we can add a redundant extern in here, that is fine. We can have a static int foo, we can have an extern int bar. Right? Right, this is the storage duration, not the linkage. So both have static storage duration, but this one is internal and this one is external. Okay, so that works. Then we need to, so I'm too lazy to now test every declaration. I need to write a test at some point. Now we need to, like, there are a bunch of code that we are not handling, like we can do register int main, right? Which is illegal. And we can also handle it in a forward declaration, which are different places, unfortunately. So let's add a type specs. So bool is valid. Well, okay. It's valid for parameter. So parameter, a bit of refactoring here. So the parameter check, so it's only valid if we are not having a linkage and we're not having a storage duration, which means like no storage duration was explicitly specified. And it must not be constexpr. Valid, same thing for cast. Okay. And then we are having is valid for function. So a function, can a function ever has no linkage? I don't think function will always have some sort of linkage. Yeah, let's just say like linkage. So the linkage must not be none. We must not have a storage duration because the function doesn't have storage. And we don't have constexpr function in C. So that's a check. So type name in parents, and then here we can do use db type store dot is valid for cast. But I just wrote parameter decl type spec is valid for parameter global declaration. So when we are parsing a function definition, we need to check if type spec dot is valid for function invalid declaration specifier for function value valid for function like so. And then when we pass a plain declarator, we also need like similar piece of code where we create the function declarator. No, not declarator, declaration. So when we're passing a declaration, right here, I should have copied the error message first. Right here, when we create a function decl, type spec needs to be valid for function. Okay. So now that is that, right? Invalid declaration specifier for function, we get those errors. And then we also like have auto, right? So now we're checking those. Okay. Is there anything, like there probably some edge case that I missed handling? Like, can you do register for a global variable? Apparently not. But oh, right, and we're checking those. But we're not checking that one. Right. So we're checking this one again because static and register both are storage class specifiers, so you can't combine them. But extern is not, so you can combine it with register. So we need to manually prevent that by essentially having like the whenever we whenever we determine that the storage duration is going to be register, the linkage needs to be none. So this means that whenever we create a variable decal, no, okay. So when we create them, I'm coaching. So whenever we create a variable decal, which is in those two places where we can have a storage duration, so we need to check. The pattern matching is a bit annoying because I want to do this check and then I want to do the same logic for both, and I don't want to keep duplicating more and more code at this point. But I guess I can do like another lambda, create var. With this code. And then here I just return create var. As well as here. And now I can check that if the size spec that storage duration is storage duration register and the linkage so if we don't have a linkage or the default linkage is not linkage none, then we want to issue an error. Invalid combination of linkage and register storage class. Like so. Right. Invalid combination of linkage and register storage class. So that's that. Okay. So let's just say we are handling all of those specifiers correctly, catching all the errors that might appear. I wonder whether you can combine like register, like this one's fine. I wonder whether you can combine that with constexpr, was what I'm about to ask. So let's combine that with constexpr. Apparently. Like, I mean, just because a compiler accepts this doesn't mean that you can, but okay, let's not worry about that. I'm curious, what does it say like when we have a local variable? It says register and it is constexpr. Okay, but it has no linkage. Okay, so what about the effects? So we are half-heartedly exporting functions if necessary in Kotlin. So if the linkage is external, we are exporting the function. This doesn't have any effect since we are a bytecode interpreter. So we also can't export globals, but again, because we are a bytecode interpreter, it doesn't matter. Like linkage has no effect. The storage duration itself is something that we do need to handle. But let me commit first. So parse or more declaration specifiers. Okay, so two things that we need to handle. First thing, this is now a global variable. This food. This is not a local variable, this is a global variable. This is not, but we are treating it as a local variable, right? Because of the storage class. That's something that we need to handle. And then the second thing is this is not allowed. You cannot take the address of something with register storage class. So we need to that one is easier to fix, so let's do that first. So we've got a function somewhere as L-value, and an identifier expression is not always an L-value, because it might be classified with register. Storage class ID, we want the declaration. So if it's a variable, so if we're referring to a variable, clog variable declar ID declaration, then the storage duration must not be register. Otherwise we're good. Right. Another type for unary operator. So that's an easy fix. Don't turn register variables into L values. Okay. The other thing is a bit more tricky. Because what this actually means is that it's not that tricky to do. This one's not that easy. This one's quite easy. Essentially, when we reach codegen a function, what we need to do is if so let me refactor that one a bit. Oh wait, var deckel. So if the storage duration is static, then we need to do something different. So if it's not static, we create a local variable. Otherwise, we add a global variable, which may or may not be so let's just create a mutable global variable unconditionally. This is the wrong piece of code. This adds the parameters, which isn't clear what doing. So parameters don't have a storage duration. When we right here, variable deck. This is the one. Okay. So here's where we need to check the storage duration. So storage duration is static. Else. So we need to add a global. Add global. Let's just make it unconditional. Yeah. We need to add a global. Data. Let's refactor. So this function. Codegen type. So we also have function. Codegen function. So right above here. Adam global. Codegen global. Context. Decker. And then we're returning the global. So here we're just calling codegen global. Context and decker. And where we were before, somewhere inside codegen function, where we're parsing a declaration right here, we need to add a global instead. Okay. So now we've got foo as a global. Right, that is our foo. And we can print that. Apparently not. Apparently then we're crashing. So we can't give it an initializer, then we are crashing for some reason. Okay. That's a bit unfortunate. Why are we crashing? The compiler takes a long time to compile because Lexi does a bunch. Member color null pointer. Huh, that should be easy to debug. Oh, shit, it's in the bytecode. Oops, that's not good. That we're crashing somewhere inside the B. Wait, in this execute? Oh, we don't have bytecode. Apparently, why do we not generate bytecode? As soon as we have an initializer, we're not generating bytecode. That's odd. Why are we not generating bytecode? Oh, I know. I think I know what the issue is. So the issue is that while we are inside CodeGen Global, we are switching the builder. So we are switching the builder right here over to build the chunk, not the function, which means that then we discard everything that was being built in progress, which is annoying. That's some okay. I'll fix. Okay, let's fix that by creating a new builder. So we need to create a new builder for you. Default build option, context. Out builder is the context.builder. Then we're creating a new builder. And then we are returning back to the out builder. Context.builder. Okay. And now that works. Okay. So this now creates a global properly, and because like if we have another function bar, this one works. I thought it would. Maybe it doesn't. Requested exit block has different output count. What? So we've got a function R. Why are you? That one works. That one doesn't work. Huh? That's really odd. Okay, so apparently we can't have an initializer in here now. What? Why not? Okay. Okay, I mean, the stream is getting, like, I wanted to end a couple of minutes ago, but keep finding more and more bugs that I need to fix. So we added, let's investigate that sometime else. So we've got that. The thing that is, we also got like that, but the thing is extern. We don't handle that properly yet, because this creates a definition of foo, whereas it's only a declaration, right? And then this creates the definition. What's that? This creates the definition, but we're not handling that. I guess we do. No, we're printing 0. We're not printing 11, so we're not handling that. Okay, but that's definitely something I'm doing. So support global function local static. This is something that we'll do next week. Thanks to everybody who stopped by, and until then.